Stars and galaxies. We've talked about ancient observers around the world who have looked up at the night sky and they've always seen groups of stars forming pictures of people or animals. Today we call these patterns constellations. Astronomers use the patterns of constellations to locate objects in the night sky. Although the stars in a constellation look as if they are close to one another, they generally are not. They just happen to lie in the same part of the sky as seen from Earth. Just like the sun, all stars are huge spheres of glowing gas, and they are mostly made up of hydrogen and use the process of nuclear fusion to produce energy. This energy makes stars shine brightly, and this feature helps astronomers classify stars according to their physical characteristics. Characteristics used to classify stars include color, temperature, size, composition, and brightness. If you were to look up at the night sky, you can actually see slight differences in colors of the stars. For example, Betelgeuse, the bright star in Orion's shoulder, looks reddish, while Rigel, the star in Orion's heel, is bluish white. This is due to the different temperatures of the stars. Stars also seem to be the same size, but actually many are the size of the sun, which is about a medium-sized star, and then there are stars much larger than the sun called giant stars or supergiant stars. If the supergiant star Betelgeuse were located where our sun is, it would be large enough to fill the solar system as far out as Jupiter. Now, how bright a star looks from Earth depends on both its distance from Earth and how bright the star truly is. Scientists measure how bright stars appear from Earth using a scale with numbers called magnitudes. The apparent magnitude of an object is the measure of how bright it appears from Earth. When we discussed measuring the planets or the distance of planets, we used an astronomical unit, which was the average distance between Earth and the Sun. However, stars are at a much greater distance, so astronomers measured distances to objects beyond the solar system using a larger distance unit, the light year. Now, despite its name, a light year measures distance, not time period. A light year is the distance light travels in 1 year. Light travels at a rate of about 300,000 kilometers per second. That means 1 light year is about 10 trillion kilometers. Proxima Centauri, the nearest star to the sun, is 4.2 light years away. Scientists study the spectra of stars using an instrument called a spectroscope. A spectroscope spreads light into different wavelengths. Using spectroscopes, astronomers can study stars' characteristics, including temperatures, compositions, and energies. Stars also vary in their chemical composition, having hydrogen, helium, sodium, and calcium. Astronomers can use tools called spectrographs to determine the amount of these. Like living things, stars also have life cycles. They are born and then after millions or billions of years, they die. Depending on their masses, stars die in different ways. However, all stars are born the same way. Stars form deep inside clouds of gas and dust called a nebula, and star-forming nebulas are cold, dense, and dark. Gravity causes the densest parts to collapse, forming regions called protostars, and these protostars continue to contract, pulling in surrounding gases. When their core gets hot and dense enough for nuclear fusion to begin, they produce enormous amounts of thermal energy. Over thousands of years, the energy produced by protostars will heat up the gas and dust surrounding them. Eventually, this gas and dust will be blown away, and the protostars become visible as stars. Now, how long a star lives depends on its mass. You may think that the stars with more mass would last longer than stars with less, but actually the reverse is true. Generally, stars that have less mass than the sun use their fuel slowly and can live up to 200 billion years. Medium mass stars like the sun live for about 10 billion years, and astronomers right now think that our sun is about 4.6 billion years old, so it's about halfway through its lifetime. And of course, stars that have more mass than the sun have shorter lifetimes. Now, when a star starts beginning to run out of fuel, its core shrinks and the outer portion expands. Depending on its mass, the star either becomes a red giant or a supergiant. The red giants and supergiants evolve in very different ways, and after a star runs out of fuel, it will either become a white dwarf, which is a blue-white core of a star that is left behind and cools, or it may become a neutron star, which are the remains of a high mass star after a supergiant explodes, or it may become a black hole, which is an object with gravity so strong that nothing, not even light, can escape. Now, our solar system has only one star, the sun. However, most stars are in groups of 2 or more stars, and these are called star systems. Star systems that have 2 stars are called double stars or binary stars. Those with 3 stars are called triple stars. The nearby star Proxima Centauri may be part of a triple star system. Many stars belong to larger groups called star clusters, and all of the stars in a particular cluster formed from the same nebula at about the same time and are about the same distance from Earth. Galaxies are huge groups of single stars, star systems, star clusters, dust, and gas bound together by gravity. There are billions of galaxies in the universe, and then some of the largest galaxies have more than 1 trillion stars. Astronomers classify most galaxies into the following types: spiral, elliptical, and irregular. Spiral galaxies look somewhat like a pinwheel, where it's a galaxy that appears to have a bulge in the middle and arms that spiral outward. The spiral arms contain many bright young stars as well as gas and dust. Our solar system is located in the spiral galaxy called the Milky Way. When you see the Milky Way at night during the summer, you are looking toward the center of our galaxy. The center of the galaxy is about 25,000 light years away, but it is hidden from view by large clouds of dust and gas. Elliptical galaxies look like round or flat balls, and these galaxies contain billions of stars, but have little gas and dust between the stars. Most elliptical galaxies contain only old stars. Some galaxies do not have regular shapes and are known as irregular galaxies. These generally have many bright young stars and lots of dust and gas to form new stars. Astronomers have also discovered distant objects that are enormous and bright and that almost look like stars. These objects were given the name quasi-stellar objects or quasars, since the word quasi means something like. Astronomers believe that quasars are active young galaxies with giant black holes at their centers, and each of these black holes has a mass 1 billion times or more that is great as our sun. Now, astronomers theorize that the universe began billions of years ago, and at that time, the part of the universe we can now see was no larger than the period at the end of a sentence. This tiny universe was incredibly hot and dense, and then the universe exploded into what astronomers call the Big Bang. According to the Big Bang theory, the universe formed in an instant, billions of years ago, in an enormous explosion. And since the Big Bang, the size of the universe has been expanded rapidly. Evidence to support this was discovered by Edwin Hubble, an American astronomer in the 1920s, when he found that the galaxies are moving away from us and from each other. Hubble's law states that the farther away the galaxy is, the faster it's moving away from us. And this law strongly supports the Big Bang theory. Okay, that's a lot of information. Let's take a break, and it's time for you to show what you know.